In this video, we're going to look at an example of using the ratio test. So to remind yourself about what the ratio test says, I have it here. We have an infinite series with positive terms, and we are going to find the ratio of two successive terms by taking a sub k plus 1 divided by a sub k, and we're going to see what happens to that ratio as k approaches infinity. So we're going to look at that limit. If that ratio is between and including 0 up to 1 and less than 1, the series will converge. If it's greater than 1, the series diverges, and if the ratio is equal to 1, then it's inconclusive. So here's the example we want to look at. Use the ratio test to determine if the series converges. So again, what we want to do is we want to look at the limit of the n plus 1th term divided by the nth term. Limit as n approaches infinity of a sub n plus 1 divided by a sub n. So in this case, right, your a sub n is this guy right here. Your a sub n is 0.8 to the n over n squared, this sequence. So we're seeing what happens to the successive terms of this sequence. Alright, so let's see what happens here. So the a sub n plus 1 term, the n plus 1th, that's hard to say, term is going to be found by just substituting n plus 1 in for these values right here. So it's going to be in for n. So it's going to be 0.8 to the n plus 1 over n plus 1 squared. And then we want to divide that by a sub n. So remember, another way you could think of this, and it's actually nicer when you have fractions, think of it as a sub n plus 1 times 1 over a sub n. And since a sub n is a fraction, then we're going to flip that over, right? So we could multiply that by 1 over a sub n, which is going to be n squared over 0.8 to the n. Alright, so before we start thinking about the limit of this, we want to simplify this fraction. And in all these problems, a lot of these problems, because you're doing the n plus first term divided by the nth term, you're going to have some canceling or some reducing or some simplifying that you can do. So we want to look at these two guys here, and we want to think about how we could simplify that. So we have a common base, and so when we have a common base and we're dividing, we're going to subtract the exponents. So when we simplify that part of it, we're just going to have 0.8 to the first power in our numerator. Just 0.8, right? So like if this was 0.8 to the third and this was 0.8 to the second, you divide those, you just end up with 0.8. Now as far as the n squareds go, we can't really cancel anything here, so we're just going to write that as n squared and n plus 1 squared. Maybe we'll write this out. You know, if this was to the 5th power or something, I wouldn't suggest multiplying it all out. You can kind of think about what's going to happen as n approaches infinity without multiplying this out, because you know you're going to have a polynomial of degree 2 in the numerator and a polynomial of degree 2 in the denominator in this case. And so the limit as n approaches infinity is going to be the ratio of the coefficients of the leading term, right? So it's going to be 0.8 divided by 1. That's what's going to happen with this guy. So that's a property of rational functions. So this limit is going to come out to be 0.8. Alright, let's go back and look at our ratio test again. What does that tell us? This is our R value here, right? This is our R value, not our ratio test. Sorry, yeah, the ratio test here. So our R value is 0.8, so that's between 0 and 1. That's our R value here. So that tells us that this series right here will converge. Sometimes written with a nice little symbol like that. That will converge. Now what does that sum converge to? I don't know. This test doesn't tell us what it converges to. It just tells us that it does converge.